Hi everyone, today we're going to talk about why Enlist herbicides have near zero volatility and some of the benefits that this chemistry brings to the marketplace. If you look back in the past, really with all herbicides that we apply, there's three mechanisms that herbicides can move off target, including Enlist herbicides. That is physical drift, if we spray in high wind scenario and the particles move from the sprayer and never hit their intended target. The second is tank contamination, which you may have seen in a prior video. That's where we're not getting our sprayers clean before going into a susceptible crop. And the other one is if we spray into an inversion. It's a stable air scenario and they can be moved off target in a later scenario. More commonly here in the past few years, volatility has become a common term used in the agricultural sector. Volatility is the phenomenon where spray droplets hit their intended target and that herbicide converts from a liquid to a gas and becomes airborne. And once it's airborne, it can be blown in any direction that the wind is going. So volatility is extremely concerning when talking about especially auxin herbicides because plants are susceptible to auxin herbicides. What's fascinating about the Enlist herbicides, both Enlist 1 and Enlist Duo, is they feature the 2,4-D choline molecule. And that 2,4-D choline molecule brings us near zero volatility with Enlist herbicides. So let's take a look at how the 2,4-D choline molecule reduces volatility. So on this board, we're going to talk about the benefit of the 2,4-D choline molecule. But first, I want to talk about the older formulations of 2,4-D. This is what I call my granddad's 2,4-D, the 2,4-D amine or 2,4-D ester molecule. If you think about how chemists formulate these products where they're both active on weeds and stay in solution so that they're workable for farmers, is we take the acid form of the 2,4-D molecule. The acid form is actually what penetrates weeds and has activity on those and results in weed death. We formulate these with salts, right? Because salts helps it stay in solution and also penetrate the leaf cuticle. So these salts are really important for workability of these products. Now with an amine formulation, these salts can disassociate from the acid. The acid portion of these molecules are highly volatile. Okay, this is what we have to mitigate forming is the 2,4-D acid if we want to reduce volatility. So the goal is to reduce the formation of 2,4-D acid. And Corteva went back to the drawing board and came up with the 2,4-D choline molecule. Okay, the 2,4-D choline has a double bond with the 2,4-D acid, and it does not readily disassociate in solution. So that gives it a lot of stability, and the 2,4-D acid molecule is never formed. Therefore, we have near zero volatility with Enlist herbicides. Some of the common tank mix products that we use reduce spray solution pH. And pH really causes these particles to disassociate if you're talking about the amine or ester formulations. Products like glyphosate, glufosinate, and AMS can drop your spray solution pH, and that'll cause higher disassociation and more volatility. The 2,4-D choline molecule eliminates those issues, and we have near zero volatility with Enlist herbicides because the choline salt does not disassociate from the acid. This is a great benefit, and it's really why the EPA allows us to mix the AMS products, glufosinate and glyphosate products with Enlist herbicides is due to the 2,4-D choline molecule. This is why Enlist herbicides have near zero volatility. Now let's take a look here at a comparison. My first question is, how does Enlist herbicides and the near zero volatility that they bring compare to the competitor's product on the marketplace? Competitor's product is going to be the Batma salt of dicamba. In this situation, we mixed it with glyphosate. As I talked about earlier, glyphosate reduces that spray solution pH and causes the salt and acid to disassociate in the dicamba scenario, increasing volatility of that product. Here with Enlist Duo, which is a premix of straight goods 2,4-D choline plus glyphosate. So same herbicide mix except the 2,4-D molecule here. As you can see, even under a stress scenario where we're adding glyphosate to the tank, we're 98% less volatile than the Batma salt of dicamba. So behind us is one of the best tests I've seen to test for volatility of herbicides, not only with Enlist herbicides, but other products on the marketplace as well. What we've done here is we've planted a susceptible crop to Enlist herbicides. This is all dicamba tolerant cotton, what's behind me. We came in and we made an application of Enlist 1 plus glyphosate right in the center of it. It was about 1/10 of the area total of what's planted. So when you spray a herbicide in the center of a susceptible crop, you're going to be able to use that crop as an indicator of where the herbicide moved and if it moved after it was sprayed. So when we made the herbicide application, the wind was blowing from the south to the north, really right across our treated area. The wind ranged from 6.2 to 9.4 miles per hour. So in terms of wind speed, this was a labeled Enlist herbicide application, and we used the tips we recommend in a dicamba cotton environment where we're trying to mitigate driftable fines. Before we made the herbicide application, we actually took 5-gallon buckets and we placed them over susceptible cotton plants. And we did this to protect them from any physical drift that was going to occur during the application. This left indicator plants around the field that would show us if there was going to be 2,4-D symptomology on those plants. The only way those plants would have 2,4-D symptomology is if volatility occurred and gassed off the treated area. And we'll take a look at some of those plants, but we did not see that symptomology on the plants covered by buckets. Additionally, 30 minutes after the application, we set tomato plants in the middle of the treated area. And I think everyone knows tomato plants are highly susceptible to a lot of herbicides, especially auxin herbicides in particular. Those are a great indicator plant that we can look at and say, hey, did volatility occur at high enough rates to injure tomato plants or susceptible cotton around this area? So let's go take a look at some of these things in the field. So we're standing in the middle of the treated area where we sprayed Enlist 1 plus glyphosate 11 days ago. We stuck these tomato plants in the treated area 30 minutes after the application. These tomato plants act as indicator plants to catch any volatility that were occurring and could cause symptomology on these plants. Tomato plants are highly susceptible to auxin herbicides and 2,4-D, right? So we should see symptomology on these plants if volatility occurred at high enough rates to cause symptomology on tomato plants. As you can see here, there's no auxin symptomology on these tomato plants. Guys, we've done this for 5 years at the University of Arkansas and other universities across the Mid-South, placing plants in treated areas with Enlist herbicides, and everyone's had very consistent results. We're not seeing any volatility causing symptomology on susceptible plants. Now let's go look at the upwind direction of the field at the time of application. I'm standing in the upwind direction at the time of application. So again, the wind was blowing from the south directly towards my back, straight this way. And so these plants were not exposed to physical drift on the upwind side of the field at the time of application. As you can see, we killed cotton inside the treated area with a labeled rate of Enlist 1 plus glyphosate. With the wind blowing away from a susceptible crop, this demonstration really shows the safety that Enlist herbicides have long as the wind direction is blowing away from susceptible crops. I'm standing in the second row over from where a full rate of Enlist 1 and glyphosate was applied. There's absolutely zero symptomology on this row. So that shows you that we can really carve lines with Enlist 1 plus glyphosate long as we take into consideration the wind direction and wind speed at the time of application. Another important fact to mention at this field is that 72 hours after the application, and 72 hours is really the time period after herbicide application that volatility can occur and cause symptomology on sensitive vegetation. In the 72 hours after the application, the wind direction changed at 280 degrees. So we should see symptomology on all this cotton around me and where I'm standing if volatility was occurring from Enlist herbicides at high enough rates to injure susceptible cotton. And we're not seeing that. And we've done this for a number of years and feel very confident that Enlist herbicides have near zero volatility. Now let's go look at the physical drift plume in the downwind direction, and we'll show you what that looks like. I'm standing in the downwind direction at the time the Enlist 1 and glyphosate application was made. As you can see, there's 2,4-D symptomology on this cotton, and we expected to see this, right? Enlist herbicides are not immune to physical drift, they're not immune to spraying in an inversion, and they're not immune to someone not cleaning their tank out very well. We can see physical drift with Enlist herbicides, and we expected to see this plume here. The drift from this herbicide application, again, the application was made at 6 to 9 miles an hour. It went about 14 rows into this field. One of the cool things about doing an experiment like this is we protected the cotton plant right under my feet from physical drift with the 5-gallon bucket. So we placed a 5-gallon bucket over it when the herbicide application was made 30 minutes after we removed this bucket. This plant has never been exposed to physical drift, but it would have been exposed to any volatility occurring from the treated area and moving off target. So what we have here in the center, these two plants were covered by a 5-gallon bucket when the herbicide application was made. We're directly downwind of the herbicide application, or directly downwind from the herbicide application. So as you can see on the plants next to it, we have symptomology, 2,4-D symptomology on this cotton. We expected to see this physical drift from Enlist herbicides this close to the treated area. But the plant protected by the 5-gallon bucket at the time of application is showing no symptomology from the Enlist herbicides. That's because they were protected from physical drift. However, these plants should have been exposed to any volatility occurring from the treated area. This is a great indication that Enlist herbicides have near zero volatility and does not move off the treated area.